Okay, let's look at the homework 3.2, 3.3, number 3. Right? So we have this function f of x is given, and we want to find the local relative maximum and the relative minimum. Right? So let's do that. All right. First thing we do is that since this function is not defined everywhere, so we look at the domain. So domain of this function is going to be all real numbers except 0. So x cannot be 0 because 0 make the denominator 0. Right? So first thing we do is I'm going to just rewrite the function so that I can take the derivative more easily. So you have x. Right, 49 over x can be written as 49 x to the negative 1 power. Right, so let's take the derivative. So f prime of x is equal to, right, derivative of x is 1, right, derivative of 49x to the negative 1 is, let's see, negative 1, put it in front, negative 1 times 49 is negative 49, right, x, then subtract the 1 from the power, so it's going to be negative 2, right? So we're going to just clean up a little bit. So this is the same thing as, right, 1 minus, right, 49 should be on top, right? Since it's a negative power, so we can put x squared on the bottom, right? Then I'm gonna take the common denominator. So 1 is same as x squared over x squared. So that's equivalent to 1. Then you have minus 49 over x squared, right? Luckily, we can factor out the top, so go ahead and do that, right? This is going to be x plus 7 times quantity x minus 7, right, all over, right, x squared, right. Now we can easily set this equal to 0 to find critical numbers, right. Then you just have to worry about the numerator being 0, so it's quantity x plus 7 times quantity x minus 7 is equal to 0, right, which gives you x equals minus 7, negative 7, and a positive 7, right? Those are the critical numbers, all right? Then we know that local relative max and relative min occur at the critical numbers, so we will check which one it is, all right? So we're going to do a number line, all right? So first thing we need to put is that since the domain is all real numbers except 0, so we have to put 0 there. And also critical numbers are negative 7. Right, this is negative 7 right here, and positive 7. Right? Then we just have to look at the sign of the derivative, so f prime. Right? So anything less than negative 7, so I'll try negative 8, right? If you plug in negative 8 here, maybe here, right? Negative 8 squared is going to be 64 minus 49, so that's positive, over x squared is always positive, so positive divided by positive, so it's going to be positive here, right? Between negative 7 and 0, I like negative 1, so I'll try negative 1 as a sample number, right? Then plug it in, so it's going to be 1 minus 49, so it's negative, over positive, so it's going to be negative here, right? And between 0 and 7, I'll probably try x equals 1, right? 1 squared minus 49 is negative, over positive is still negative, right? After that, we can try x equals 8, right? 8 squared is 64 minus 49 is definitely positive, over positive is going to be positive, right? So you can see that by using the first derivative test, right? So original function f is increasing on this interval, and after that it's decreasing, right? Because it's negative here. So which means that we're going to have a relative max at x equals -7. And here we don't have anything because function is not defined there. But when x equals +7, since it's going from decreasing turn into increasing, we know that this is going to be a relative minimum. All right, so let's find those values. So we can have, let's say, plug in -7 there. All right, so if you plug -7 there, you have a -7 plus 49 over -7, right? 49 over -7 is -7, so you have a -7 minus 7, so -14, right? And so this guy is the relative, this guy is, oops, this guy is relative maximum, right? All right, the other guy is f of 7, right? Is equal to, of course, 7 or plus 49 over 7, right? That's 7 plus 7, so it's 14, right? So this guy is actually relative minimum, right? So let's type it in. All right, relative max is going to occur at -7, comma, -14. All right, and maybe I'll put space there. And the relative minimum occurs at the 7, comma, +14. All right, it is okay, perfectly okay to have a relative minimum, which is 14, bigger than relative maximum. All right, let's check the answer. Okay, I came back. Looks like we got them correctly. All right, that's it. I hope that this was clear.